on this. Okay. Hi, everyone. So this is the Kubernetes batch working group weekly meeting. This meeting will be recorded, uploaded to YouTube. Please adhere to Kubernetes guidelines. So one of the things that we discussed last time was the working group roadmap. And we've talked about, let me present the roadmap. So we discussed the three working streams, and one of the things that we talked about as well is, trying to establish the status quo, like what the current status of ongoing activities. So I reached out. Now we have three working streams. I reached out to Swati. She will be organizing this effort with regards to specialized hardware support. So she already have the topology-aware scheduling. Like she's collecting information about that, and the other two issues related to node feature discovery. So she'll be reaching out to the owners, try to establish, like a proper current state documented, so that we can, discuss what we need to improve in that work stream. Now, on our side, last week we discussed mostly the job management. We wanted to do something similar as well. So Diane and Aldo, they created a template for presentations for existing batch schedulers. So the starting point here again is to understand what existing batch schedulers that were built on top of Kubernetes are doing, what are their main pain points. And then from there, we can start to, define our recommendations for enhancements within Kubernetes to support job management. So the first work stream with regards to job API, I think they kind of intersect with job management. But I feel that at some point we want to have, because it's a large scope, like we have three things that we want to talk about, etc. Maybe every week we focus on only one and try to make progress only within one work stream in some capacity. So for today, we're not going to talk about job API, although we have some comments here from others commenting about how we can, what we can do more, etc. But just so that we're focused, we will be talking today about the job management. We have our first guest from Tecton. And I want to give it to Diane or Aldo if you want to present and discuss the template quickly, just to set expectations of what we're trying to, get from these presentations.
Sure, I can just do I'll say something quickly and verbally. You don't have to show the template, but the whole goal that we, Aldo and I have been working on is really just to try to get a good grasp on the challenges that these solutions have provided, the challenges they've had to overcome with regards to requirements, and able to map those into the Kubernetes resources. So we put together just a simple template to try to hone in on, how we might understand at a high level and in some detail the patterns that were being used, what were the gaps that they were trying to accomplish, what are the workload requirements that they weren't able to solve with the Kubernetes core components, and then just some insight on how they did some deployments, how they do their deployments and their workflows. So it's really intended to try to gather, these high level patterns so that we can, take them on and find out what we can extract to start to focus in on this workload.
Thank you, Diane. And So like, it would be good if someone can take notes. I can take notes as well, but if someone else is interested in taking notes for the Tecton presentation, that would be great. Any volunteers?
I can try that in the same doc, or should we have separate one? A separate one.
I would keep it in the main agenda doc.
Yeah.
There's no reason that we have to keep another one. It will be good to reference if you want to have a high level overview. I'll help with that one as well. So the two of us, we should handle this.
Since we will have a few presentations, I mean, today I guess we can do it there so everyone can see, but maybe we can next time have a link to a separate doc exclusive about all the presentations that we had, so we don't lose them. One more thing I wanted to say about the template. So of course, it's not set in stone, it's just a reference. If you are a maintainer of any project, feel free to just suggest your presentation in the agenda, or if you know a maintainer of a specific project, please invite them to present. That's it.
All right. Any other comments, suggestions, or before we hand it to Jason? Sounds good. Let me make Jason. Do I need to give you co-host? Make co-host, right? Represent?
Yeah, it's saying a participant can't share the screen. Host disabled participant screen sharing.
How about now?
Maybe. Yes, this seems to be working. All right, one sec. Are folks able to see that?
Yes.
Okay, excellent. You see Tecton, you see a big RoboKitty. All right. Excellent. Yeah, first of all, thank you for the outline for the template. That was very helpful when putting this together to know, sort of the things you all were interested in hearing. I'm going to not include a lot of stuff about Tecton in this and focus on the stuff that I think is most useful to this audience. I also, I think we'll have tons of time for questions and everything. And I saw that Vincent and Andrea are also here, potentially others from the Tecton community. So if we have time for questions, there will be not just me to help answer them, which will be good. All right, well, yeah, thanks for having me. My name is Jason Hall. I work at Red Hat, and this is a presentation and overview of Tecton. So Tecton is a CI/CD workflow engine. Oh God, I've clicked a button and now I don't know how to stop it. Okay, a CI/CD workflow engine on top of Kubernetes. It's based around ephemeral build containers. This prevents a lot of supply chain attacks, things like SolarWinds and things like other build systems before Tecton. You'd have long-running build agents that wait for jobs and then do some stuff. And those long-running persistent workloads meant that if you infected or compromised or did something to that long-running workflow or that long-running build agent, that you could infect future builds. And that's roughly at a very high level what happened with SolarWinds, and there have been a number of similar attacks. Tecton is not that. Tecton just aims to be very ephemeral in its build process. And also aims to, like, one of the value propositions of Tecton is that you can secure your build pipeline, your build cluster, using the same tools and experience and knowledge and operational knowledge as your prod cluster. So you're using Kubernetes, you know how to lock down permissions, you know how to lock down RBAC, you know how to observe things and watch for threats because you run these in production. You can also use that to maintain, and observe and operate and extend your build cluster. Tecton is very CI/CD focused. It's not probably going to be as focused on raw throughput as a lot of the stuff that a lot of the other projects that this working group will probably talk about. And it's more interested in isolation and flexibility. So when we're talking about what workload we're running, we're not like taking a string and base 64ing it and passing it along the pipeline. We are like compiling code. And some compilers are very good and very, secure and very knowledgeable about boundaries. And some just have no problem putting files every damn where and, like assume that they completely control the environment. And so we need to account for both the like very well-mannered ones and the very non-well-mannered ones. And that's just like build, like even on top of that, deployment processes, golden file generation processes are completely open-ended and users can and will do whatever they want. So we don't focus as much on throughput as many of the things you'll probably talk about in this group, but we are very interested in isolation and flexibility. Pods are never reused. We spin up a pod, we run your build, we delete it. It's never going to be used for another workload ever again. And templating is also really important to us for usability, for the ability to make this flexible and powerful. Tecton is a CDF founding project. We were founded 3.5, 4 years ago. Even that's fuzzy. A number of products and services are built on top of Tecton, like as another layer on top of Kubernetes, where they build their own service or product or project. Jenkins X is one of these. Shipwright is one of these. Some products are literally a distribution of Tecton released and supported with some features. OpenShift Pipelines is one of these. Cloud Build Hybrid Worker Pools is a service that Google is working on to do this. Kubeflow has work that runs Kubeflow pipelines on top of Tecton. So it's both a thing you can use directly and a thing you can scaffold build on top of other services, other products. And also I want to point out, Tecton runs on Kubernetes and very often deploys to Kubernetes, but it doesn't have to. Based on bug reports we've gotten, people use this to build and test mobile apps, to build game engines, to build all kinds of stuff that has nothing to do with Kubernetes at the end of the day. But being able to isolate and operate your build cluster on Kubernetes is really useful. So wherever it's being deployed to, having it run on Kubernetes is really nice. A brief overview about the architecture. First, we'll talk about the API that users interact with. We can either go top down or bottom up. This is more of a bottom up approach. People tell me both ways are good. The main core bottom thing that we run are called task runs. Task runs have steps, which are defined as containers that execute sequentially in order. That's redundant. Execute sequentially. That's also a typo. Excellent. This is literally using the same container spec, more or less, as what you see in a pod, what you see in regular Kubernetes. Those steps have a workspace volume attached to all the steps by default. You can attach other volumes if you need to share other data between the two, but basically, if you write something to /workspace/foo in step 1, you can read it in step 2 by default. We have a notion of results. If you write data to this magical path, Tecton results foo, Tecton will collect that data and surface it in the API. And parameters as templatized inputs to these things. You can also pass results from previous task runs into inputs in other task runs. We also support sidecars. So I said before, steps run in order, but you can also say run these, these 3 containers for the lifetime of the task run alongside. Those are useful for things like services you want to test, or if you're pushing to a Docker registry that you just want to have for the lifetime of that pod. That's an option. So task runs run everything sequentially in order and are pretty self-contained. Pipeline runs are the next level above that and are a collection of task runs that execute in a DAG, in a directed acyclic graph. So this is where one task run's results can be passed into another task run as an input. And then you can stitch them together and you can say these 5 task runs all depend on this input. So they will wait until the first one finishes. And when that one finishes, those 5 task runs will kick off and start and do whatever they want. So there's fan out, there's fan in, there's, I'm not going to go much into it, but there's conditional execution. Task runs and pipeline runs can be canceled. They can have timeouts. You can, attach other workspaces, other volumes. I'm probably missing a ton. We've talked before about having task run steps also execute in a DAG. Right now, like they are only sequential and concurrency comes from the pipeline run. We've talked about having task run steps be in a DAG. I don't know if that's really going to happen, but we'll see. And the last one is tasks and pipelines. So I mentioned earlier that we're very interested in making these templatizable. Task run, when you create a task run, it starts running, it starts doing something. But you can create a task, which is sort of an inert template for a task run, and say, this task represents fetch a Git repo. It won't, when you create it, it won't go fetch a Git repo, but it represents the concept of fetching a Git repo. And then you can instantiate it into a task run with an input to say what Git repo to fetch or whatever. You can do the same with pipelines and pipeline runs. You can have a generic deploy to prod pipeline that takes a param for what Git repo to watch or what Git repo to pull source from and what prod means. You can make it even more generic and just say deploy code to environment, where it takes both code and environment as inputs, blah, blah, blah. We have a catalog and a hub UI to share common task definitions. These things like fetch a Git repo is very common and build a container image is very common. So those are shared resources that you can sort of pull off the shelf. These are the shelves. I'm also not going to go into a ton of other stuff unrelated to this. I mean, Tekton's a huge topic, but there's Tekton triggers, which let you translate incoming webhook requests from like, from your GitHub integration. Also that has like Knative eventing compatibility if you want that. Tekton Chains is a new project, relatively new project to produce a bunch of supply chain artifacts for downstream consumers. We also have upcoming work on Tekton workflows, pipelines as code, custom tasks, dashboard, CLI. There's a lot going on, but I'm not going to talk about any of that. Yeah, like I said before, the implementation, the actual like moving parts inside of Tekton pipelines is the task run. When you create a task run, we validate it and then we translate it to a pod. A lot of the pod specifics are leaked through the API. So you can set node selectors, you can define node affinity, you can select a custom scheduler the same way that you can for a pod. We don't do anything. We don't, Tekton doesn't come with a custom scheduler. We've talked about it, but I don't think it was really worth the maintenance burden to do that. So we just rely on the regular Kubernetes scheduler. We have a controller that watches the pods we create and updates the task run status to say like, you're on step 3 of 5 and now you're on step 4 of 5. Oh, it failed, things like that. Steps are sequentialized by injecting an entry point binary, which is probably the largest hack I've ever been proud of. Steps aren't dynamic, so you can't, a step 3 can't say there are 3 more steps, like, add 3 more steps to the end of this workflow. There, you say these are the 5 steps to run and they run them. Results are surfaced when, remember when I said, like, if you write to Tekton results foo, it magically gets bubbled up. That magic is powered by termination message paths, which is maybe the second biggest hack I've ever been proud of. But that's really nearly going to go away because we really need to be off of that. Termination message paths are very, very limited. You are limited to 4 kilobytes per container and 12 kilobytes total per pod, which is not a lot of data to exfiltrate from your build system. We're exploring a lot of our alternatives. We have some ideas, but yeah, that's sort of a big thing we need to fix. The pipeline run controller does sort of kind of what I mentioned before. It watches for task run statuses. When one task run in the pipeline run finishes, it says, did anything depend on this? Go start those and then wait until either something fails and the whole pipeline run crashes, or we run out of stuff to do and then it's successful. Yeah. And it's responsible for passing results out of one task run into the inputs for the next one.
So steps within a task run are not modeled as a object API or resource on its own. It's just pods. The only two resources that you have are the task run and the pipeline run. Is that true?
We have many resources, but the two that the core main ones are for at least what I think we're probably interested today are task runs and pipeline runs.
Right. Okay. So the pipeline run basically includes multiple task runs, like you present them using a tag. Within the task run, you have the pod template for each step.
Yeah. So each task, I should have presented a snippet of like what a task run YAML looks like. But basically, there's a steps array, a steps slice of containers. And it runs the first one, and when the first one's done, it runs the second one, and et cetera. And you can set, there is also a pod template support for things like the node selectors and node affinity and scheduling and stuff like that, and service account name and all the usual suspects. There's one of the things in the template which I thought was useful was the administration workflow. You can install Tecton just by applying this one large generated YAML. We also have an operator which you can install. It among many other things, like setting a lot of config stuff. It also lets you control pruning and object retention. So each task run that executes is an object that we store in etcd that we reconcile until it's done. And by default, those don't go away. So you can imagine over months and years, you just accumulate thousands, tens of thousands, hundreds of thousands, and oops, etcd just exploded in your face and took down the rest of the cluster too, which is really exciting. So the operator is also responsible for, you can configure, keep only the last week's worth of task run and pipeline runs, or keep only the last 100 of those objects or whatever. All of the images that come in the operator and in the release are signed. I don't know why I mentioned that, but that's true. For the user, once it's set up, either via the operator or just by installing that YAML, you can create a task run object and watch it using kubectl. There is also a CLI that we build that has nice wrappers for it, like start this task run, or I guess it's a task.yaml. Anyway, start this task and you can pass parameters. And TKN task logs is really useful because it sort of shortcuts the annoying gymnastics of find the pod for this task run. Okay, now get logs for that pod. And like, I always forget to do -- all containers. And then there's like a -- max container limit equals 100, whatever. TKN task logs takes care of that for you. There's also TKN pipeline logs, which is even more interesting because it does that across many potentially concurrent tasks all at once and interleaves them together. So that's really nice. There's also a dashboard UI project. There's product specific and downstream specific UIs and CLIs and wrappers of all kinds. For operations, we have basically two components that we install in the cluster. That YAML that you install sets up a bunch of RBAC and creates stuff, and then basically just creates two deployments. One is the controller deployment. It watches all Tecton resources. It's responsible for creating pods and watching those pods. For pipeline runs, is responsible for creating those task runs and watching those task runs and updating statuses. By default, it's I think in that YAML, it's replicas 1, but we do support leader election and sharded work queues if you want a more disaster resilient controller. If that controller is down, running workload pods will still run, right? Like the controller is not in constant contact with the pod it starts. It just shoots a pod into the API server and then is responsible for watching it and updating the task run. So if the controller is down for any reason, your work is still running, but you may not see the updates for it. So short outages are invisible to you, but longer outages might be bad. We also run a validation webhook. We do a ton of validation, an absolute ton of validation. for instance, when you give us a pipeline run, we have to validate that it actually represents a DAG. So like, are there any cycles in the set of tasks you've given us? And a ton of other stuff. We have a lot of defaulting configured using a config map. We convert between the many API versions. And that webhook deployment also is replicas 1, but it's completely stateless and can auto scale easily if that's something you want. All the code, based on like historical reasons, all the code in Tecton is very heavily based on Knative. We actually came from Knative years and years ago, which is actually really nice. They have a lot of facility to generate informers and reconciler boilerplate. The container images for the controller and webhook and we have a bunch of other supporting containers that run inside those workload pods. Those are all built using a tool called Co. The workload pods can even run inside of Windows, which is, I think, relatively unique among Kubernetes workflow things. I don't know if we can go into more detail about whether that's needed or anything for everybody else, but I think that's an interesting thing at least. Kubernetes gaps. These are a short list, but basically real, official, actual support for sequentially running containers would be excellent. I think probably 90% of the code, well, that's high. At least a good 30% of our code could go away if we could just tell a pod to run A and then B and then C. So it is more complicated than that. Like we used to be on init containers, which do run sequentially, but that was not a very good fit and it did not last very long. One reason is we also do want those sidecar containers. So it's not as easy as A and B and C. It's start A, keep A running, run B, then C, then kill A, or, et cetera. That's a bit harder to express in a YAML-like language. These containers also support timeout and cancellation. So like run A for no more than 10 minutes and then kill it, or run A, but if the user says stop it, relatively immediately, is also not something that's very easy to describe in a declarative Kubernetes YAML. And the results collection is also another thing. We'd still have to have some way to collect the stuff people write to these magical paths. Ephemeral containers are a thing that people sometimes bring up. I think they're not a very good fit for our use case. So like at a high level, the way we could use ephemeral containers is to say like, okay, step 1 finished, create an ephemeral container for step 2. And then when step 2 finishes, create an ephemeral container for step 3. It's way too much controller interaction. If the controller's down at that time, your work is paused until it gets back up and figures it out. And I think in general, it's just not a great fit for our use case. In addition to sequential containers, if there was some better way to collect results, if there was some way to bump up even as a configuration option for admins, like the termination message path limits are hard-coded inside of the kubelet. So that would be great, but we're probably going to have to get off of that anyway. And some way to configure automatic pruning of oldest resources, either per type, like for the task run type in this cluster, never let there be more than 10,000 of them, would be something we would love to be able to say. There's quotas, right? There's ways to say like, don't let me create a 10,001st one, but that's not a great experience either. We want someone to create it, but we want something to go and delete the oldest one in that case. So I don't know if that's a feature that other folks on the call are interested in exploring more, but these are sort of this is the top 3 of our wish list of Kubernetes. There's a lot more reading and more viewing. Tecton.dev has all of our documentation. We have tectoncd.slack.com if you want to come join us in Slack. There have been a couple of talks, especially about the entry point injection stuff that myself and Christy Wilson, another maintainer on Tecton, gave in 2019. And there was a talk in last year with Alex from Argo Workflows about some of the common stuff we have, common difficulties and common solutions we've had between Argo Workflows and Tecton. And if you're interested more in that Windows thing, I also went and talked to the Kate's SIG Windows in like November, I think, about how we do that. But otherwise, that's all I've got. We have, I think, a ton of time for questions if you're interested. I will remind you that Andrea and Vincent, oh, they're even in the chat. Excellent. Both of them are here if they feel like answering the question too. That's fine.
Thank you, Jason. This is great. I've got like 3 or 4 questions, but I first want to open the floor for the community
Sure.
to ask first.
So do you use naked pods or do you have like a higher level workload API that you use for the task run or some other custom resource that you are defining?
No, so we use pods directly. I would say task runs are the higher level workload concept. Many users don't create task runs themselves. Many users just create pipelines and then start them with some parameter and watch the pipeline run that's created. So in that way, like, yeah, task runs are the workload abstraction CRD that we have around pods. But there's nothing between task run and pod. It goes straight from task run to pod.
Okay, yeah. I was asking more in terms of like, if you want to wait for completion, like we can use jobs or something like that, right? Like, was there any reason not to go with the existing API?
Yeah, so we were on jobs for a while, actually, very early on. And the reason we didn't go for that, actually, I don't think they really gave us a lot. Like it was, again, these are like create one thing and wait for it to finish. There's no reusability at all. There's no like queue that's being consumed. And in fact, also it exacerbated our etcd problem, right? Where every task run created a job, which created a single pod. And now we have double the amount of objects in etcd as 50% more objects in etcd as we used to have. So instead, if we're not getting anything out of jobs, we just create the pods ourselves. I think it's possible that there are some job features. We've like reinvented some job features inside of task runs, like retries, I think, but we, yeah, I think in general, we haven't really regretted moving off of jobs.
Sorry, like I was asking more in terms of like, if there is something in the job that would have made it useful for this use case, like what would be those features? But I believe you're saying that there are not too many.
There are none today, but if job was the type that gained the sequential step feature or the some timeout feature that was really useful, or some proactive cancellation feature, we might consider it. I do think it would have to be pretty big for a like. etcd contention is a large issue in the operation of Tecton clusters. And so it would have to be a real benefit to be worth, taking on the increase in objects we're throwing into etcd.
Yeah, I want to briefly talk about that using the garbage collector, but I think we can talk about it later.
Sure.
And yeah, that's all I have for now. Like, I just want to know if you have the list of features that would have made job useful. I think that would be helpful.
Sure. Yeah, I can offline. I can go dig up the discussion we had around that. I mean, they're 3-year-old bugs. So like we made the decision a very long time ago, and it's possible that jobs have improved enough that now we should reconsider it. But yeah.
Got it. Thank you.
Yes, Dan, I had a question, a couple questions. One was the task run. It seems that, correct me if I'm wrong, that when you're stepping through these sequential items, you don't create the pods until the previous pod is completed or reach some condition. Is that correct?
No, that's actually not correct. So
Okay.
each task run is one pod, right?
Okay.
And so when you say step 1 is echo foo, or like echo foo pipe to some file, or redirect to some file, what we take that intent and then we wrap it in a binary that we control, or a process that we control, and say actually step 1 is execute our process to do that work. that's important. For step one, that's not very exciting because it's just going to like start and do the work. For step two, that process is responsible for watching step one to finish, waiting for step one to finish, and then run whatever work it does, and then kick the can down to other steps. So in fact, each task run starts one pod. All the containers start at once in that pod, but the second step container has a process, like its process is waiting for the other one to finish, in a sequence. I'm not sure that I described that very well, but yeah, we're not creating a pod per step. We're creating a pod per task run.
Okay, and you start those off, and then those pods execute as they're defined to wait for a certain condition, and then
yeah.
Okay, got it.
And there's quite a lot of hacks involved in getting that binary to correctly wait for the previous step to finish and react to cancellation or react to timeouts and things like that.
Gotcha.
Sorry, if I understand correctly, each step is a container?
Yes.
But then you embed a entry point or something to.
Yeah, we override the entry point with our own process that either, if it's step one, execute immediately, and then signal to the next step, and if it's step two, wait for that signal, do your work, and signal to the next step, et cetera, et cetera. The 2019 talk Vincent mentioned in the chat, the 2019 talk was a lot about this. There's some of it in the 2021 talk, but the 2019 talk really goes into detail about it.
Any reason why not each step is a separate pod?
So that goes back to the controller, how much involvement the controller has to have in the workload. There's a few reasons. I think the main one is that we don't want, if you want to run 5 steps and the controller is down, you want to still be able to execute all of them. You still want to be able to make useful work while the controller is unavailable or while the controller is backed up. And so if each new step was start a pod, and when it finishes, the controller will see that pod is finished and start the second one, and then the controller will see that one finish and start the third one. That's a bit too much interaction with the controller for us. And as Andrea is saying in the chat, spinning up a pod brings a lot of overhead, especially if it's very common that 2 steps in a task run will share some volume, right? Like we'll share some state with each other. And so that means that pod has to go, if there were 2 pods, they'd have to go to the same node. They'd have to use like either a hoster directory or some sort of volume to share data between them, as Vincent's saying now. Excellent. And so really, like, for a lot of reasons, having each step be its own pod was not feasible for us.
And then my second question was, is there some concept of suspending not a task run, but a pipeline run? Or even a task run, maybe.
We've talked about it. We've also talked about being able to suspend a task run. We could in both cases, right? Like we could, I think there is actually a paused state on pipeline runs where, which just means when the controller sees a task run has finished, before it starts a new one, it will, check if it's paused. And if it's paused, don't create the next task run until it's unpaused, and then it will go. There may be a paused state in the pipeline run. I don't think it's very widely used, or at least not in my own personal experience or in my experience by handling bugs for stuff. But yeah, and we've talked about it for task runs also. You could do a similar thing where after step 2, the entry point injected binary says, oh, am I paused? If I'm paused, don't start the next one. But we really haven't gone into it very much.
Okay, great. Thank you.
Sure.
I have a question about the result collection. You've mentioned that you're using heavily termination message path. Have you considered some kind of a PVC that you could mount into the pod and then store them on any kind of storage? I don't know, S3, GC, or Google Cloud, or anything like that?
Yeah, so we have, let me go into a little more detail about what it's actually doing. So what we need to do is for the workload pod to be able to write some, like echo hello world and have the API level, have that stored in etcd somewhere, right? Have the controller be able to see it so that it knows what to pass to the next thing. Termination message paths are very good for this because you literally, like, the kubelet will collect that file and write it up to the API server for us. But again, it's very, very, very limited. We have explored and have, I think, even like some functionality in the past for storing this data in GCS or S3 or elsewhere outside. That turns into a bit of a latency issue, or I mean, like, or a reliability issue, because it's going like to some external dependency outside of the cluster, and also like an extensibility issue. So if we support GCS and S3, and somebody says, now I want you to support, Azure's storage service and my own homegrown storage service, like I fear the slippery slope. I know that's a slippery slope argument, but that I think so rather than have specific hard-coded implementations of storage for this, I would rather have something that's extensible, where we say it's extensible and we come with 3 types, and if you want to add a 4th, you can implement this protocol and do whatever you want. I think that's roughly the shape we'll have for what the replacement for this is, but it's sort of in the middle of design and not really implementation yet. The other thing you mentioned was a PV, where we could do that, but that doesn't get it out up to the controller. So if we write it to some persistent volume, that hello world I wrote is stuck in a PV somewhere, and either something has to read that PV and tell the controller about it, tell the API server about it, or the controller has to mount that PV, and like that becomes another scheduling bottleneck for everything has to run on the same node as the controller or the PV watcher or whatever. I think we did explore that also, or at least start to discuss that at some point. But I think that in general, it's going to be like probably some extensible third-party storage thing.
I mean, with PDs, you could have multiple readers and one writer, so it doesn't need to be scheduled on the same node.
Right. We actually need, depending on how we would design it, we would need multiple writers and one reader, where multiple pods on multiple nodes could write to it. Or, I mean, it's possible that we could do this with a PV, but I think it's not going to be any easier than. The other nice thing about if it is an extensible protocol, if there is some extension possibility, one of the implementations could be PVs. You could implement the protocol using just local PV storage, if you wanted to.
I want to take a more batch related question. I mean, all of this one is like it is batch related, but it seems at the higher level, like with in the concept of job management. Yeah, thank you, Ravi, for bringing up the job API and how we can better improve it for Tekton. It seems to me that you want the task run to be presented as a job. Like ideally, you would want to not have a task run, for example, CRD, and just create a job directly and be able to express those. But it seems that it's way too complicated to actually make it general enough to push it down to have it as a Kubernetes core feature. You do a lot of.
Yeah. I definitely would not advocate for a Kubernetes core task run. Like right. A lot of the stuff we do is bonkers and would not be something I think other people should do. Or I mean, people should use Tekton. I'm not saying people shouldn't use Tekton, but I don't think it's a generally applicable thing in general. But if some of these things like sequential steps were a feature of jobs or a feature of pods, or if results collection was something that existed elsewhere, we could still wrap that in task runs, but take advantage, delete a lot of our code and just use a lot of Kubernetes core functionality for that.
Okay, and I guess we can follow up on that on the slides to perhaps have a more concrete list of what potential things we can do to the job API. Maybe you will not use it yourself like in TikTok, but in general, we will try to do that. The other thing that I have I have a question about is, how do you envision this being integrated with like job queuing in general? Like, do you actually have cases, people deploying Tekton in an environment with resource constraints, and do you want to do some sort of, you know, resource management, like tenant A who's creating these workflows can't use more than X resources? At what level do you see that the queuing should happen? It seems to me here, for example, maybe at the task run level, it could also happen at the pipeline level. But I don't know if we've ever been faced with these type of questions or setups.
We've definitely been faced with the question. The main answer, as unsatisfying as it is to rely on existing Kubernetes controls for either pod resource constraints in a namespace, where you say like this namespace cannot use more than 10 CPUs, and each I mean, that's a coarse hammer to solve this problem with, but like that at least works and is not Tekton's responsibility to build, and is well known and well understood elsewhere. And the other one is resource quotas. So never let someone create more than 10 pipeline runs and the 11th will fail or something. Vincent's saying in the chat, we do take into account limit range and resource quota, but it has a lot of gotchas and limits and you know, quirks. We have been asked in general if there is some way to have concurrency limits on pipeline runs. The specific a specific use case is if you're using Tekton hooked up to your GitHub repo, you may never want to run two pipelines on the same commit, and so, or on the same PR or whatever at the same time. So if these are like deploying from PRs and you push a new commit to the PR while the previous one is still running, you may want to cancel it. You may want to queue it behind it. These are things that we have definitely gotten feature requests for, but I don't think we've come up with a satisfying answer for. You can simulate some of it either by, depending on what level you're interested in, you can simulate it either by using a custom scheduler, like building or using off the shelf an existing custom scheduler and using that scheduler when you schedule pods. Or you can also, what was I going to say? Oh, because there is a paused state in the pipeline run, you can say, you can have another controller watching and saying, you know, pause this pipeline run until this other pipeline run finishes, or, you know, until there are fewer than X running pipeline runs. It's not a great story. I'm not going to try to tell you that people like that answer when we give it to them, but that's kind of the best answer we have. So
we're actually building something like that. And that's the reason for my question is, if you have at the task run level, you think this is probably a reasonable unit of queuing and resource management. I think it is, because like when you create a pipeline run, you don't create all the task run. Right. You only create them when you need them, right?
Right.
So if you create a task run, that task run gets queued, your pipeline run will continue to wait until that task run is finished, right? And if that task run is suspended and not executing until it gets its resources and gets like, you know, and finishes, then you get all these semantics probably correctly, you know, run, right? Like, so ideally, if the task run is modeled as a job, it would have made things more natural, I guess. But we could consider it as a custom batch job that we need to integrate with.
Yeah, I think that's, I'm not sure. I don't remember the conversation we exactly when we went from jobs to pods. I'm not sure whether the concurrency limitation issue was an issue back then, and so it's possible that we decided that it was worth getting off of jobs to go to pods directly. But if that's like improvements coming to jobs, then it starts to change our calculus on whether it's worth going through that intermediary to pods, definitely.
Okay, and you already mentioned that task run itself does have the pause semantics, and it's simple, suspend semantics. It's basically if is a flag, if you suspend it, it's not going to be, like the pod is not going to get created, for example, until it's unsuspended.
I don't think task runs currently have a paused status. I think only pipeline runs have a paused status. And what that means is don't create the next task run. We don't create any sort of paused pod. We will just, the pipeline run controller just won't create a task run until it's unpaused.
Right, what I'm saying is, can we introduce a suspend to the task run itself? Let's say that basically the task run controller wouldn't create the pod until it's unsuspended. And then that would offer us that integration hook to queue task runs and do resource management dynamically, rather than that big hammer of, oh, you have to continuously create the pod and the pod getting rejected because you don't have CPU core.
Yeah, right. I should mention also when the task run tries to create the pod, if that fails, it will continually retry creating that pod. So it will look like the task run is queued when it can't create a pod. But yeah.
But it's still that is basically running your API server into yeah. Okay.
There's definitely part of the reason I wanted to come and talk here is and get feedback among all these people is scheduling is hard. I don't know if that's like the tagline of this group, but scheduling is hard. So if there's any knowledge or features or prospective interest in these things among folks, I'm definitely interested in reaping the rewards of that inside of Tecton.
Yeah, I mean, we do have that work stream on job management, and this definitely fits within that. If you have a specific, thoughts on what is missing in terms of scheduling, what we can introduce downstream or upstream, please add them to the roadmap doc, and this is all interesting. That's for sure.
Yeah, we'll do, and I'll take this also back to the Tecton community also, and point them at this also and see get their input. And if Vincent and Andrea are still here, also do that too. Because yeah.
Any other questions from the community?
More like a general comment about the pruning resources, which was your last complaint, let's call it that way, to Cube. The majority of the controllers that we have in Cube, they implement the pruning within themselves. So we don't have a general mechanism for pruning, but cron job and deployments, daemon sets, stateful sets, there are usually a configuration options which will tell, oh, keep this many old resources that we care about for this, depending on whether they failed or succeeded. And after that, it just drops them.
Yeah, I wonder if, I mean, that makes me want a common configuration for this even more, right? If every new CRD author has to go reinvent that API and reinvent the implementation of it, that's not going to be very scalable. But yeah, I guess that's what I want is somebody else to build this and for us to just plug into it using the common semantics, common API. I would hate to do the same thing, but call it prune no more than instead of like whatever the approved, if there is a single approved field name or whatever among all the things in Goop.
Yeah, just to add that, we also have a garbage collector running as a controller for the pods or the objects that do not have any owner references. So
yeah,
pods, that is not deterministic enough.
Pods do go away. Pods, when a task run finishes, it reaps all the information it can get out of the pod, like it's, did it succeed in whatever, which step did it fail at, and then we allow the garbage collector to get rid of that pod because we no longer need it, and include all the logs and everything like that.
Do you use finalizer for that?
I'm not sure I remember off the top of my head. I think we remove the owner reference for it and make it an unowned pod, and then it goes away. I'm not sure off the top of my head though.
That's not enough for preventing the garbage collection from removing it.
Okay,
You need,
I will
need finalizers.
I will go do some homework and figure out how exactly we are making sure that the pods go away. But
right. Yeah, the reason I asked that is because in job we had issues precisely because the garbage collector was removing the pods. So that's something we can advise on. But yeah, ideally we would have like you to use job, but so you don't have to do this yourself. But we can still like learn from your use case and see what we can do.
Job API has a couple other features that you like. It has TTL to finish, which is basically it's pruning. If you're using the Job API, you can set a time after which the job can be deleted after it finished. So that's one thing. The other thing, it has active deadline seconds, which is like timers on the job, like how long can it can be active. So those do exist in the Job API as well.
when let me ask you a question about that. When the deadline is exceeded, does it delete the pod?
Well,
or does it?
So for the active one, it will delete the pods. The job will continue to exist.
Yeah.
For the other one, the TTL after finish, it's basically deletes the job object, and which means all pods owned by the job will be deleted as well.
Yeah. Vincent said in the chat, we also set active deadline seconds on the pods we create. But it's worth noting that deleting pods tends to cause the logs to disappear faster also. And so that's also a UX, oh man, there's a ton of work on reaping these logs and stuff. But for cancellation in particular, one thing we've, never mind. I think that's not even true. Never mind. I will stop there instead because we're over time anyway.
Yeah. This has been really great. Like one thing that probably we can discuss over on Slack is how are you different from Argo? Like why do we have all these workflows? At least like from my perspective, it seems that there's so many of them out there. Nextflow, Argo, Kubeflow pipelines. Why are we having all these workflow frameworks?
Yeah, I think it's a reasonable question. I mean, I think some of the answer is we are each targeting slightly different things. I mean, Argo workflows has a different set of like scaling targets and a different set of throughput targets and a different set of isolation targets. I mean, like I said, the reason I think we are probably one of the slower paced things as far as like how much throughput we go through, but that's because we really need to make sure that no two users code ever touches the same pod together, or no but yeah, anyway, why aren't they all Tecton is also a question worth answering. And I'm more than happy to come and heckle when they come and talk and ask them why they're not Tecton, but I'm kidding.
Thank you very much. Any last comments from audience?
Sorry, I just have a quick question about the jobs API. Can we also mount the same volume, like for sharing data in, for example, if a job spawns multiple pods, how do we go about that problem?
If we were to use jobs, we would only allow it, we would only configure it to start one pod. Because we wouldn't want to, we don't want to run the work twice,
I was just wondering if we use the other approach of spawning pods. Maybe not. The question is not for you, Jason. Sorry.
Oh, sorry.
Anyone else has experience work? Like, for example, if you spawn multiple pods in a job, can you share volumes in them? Or you have to mount the volume separately? How does that work?
We can probably check the docs, but I believe you can have a shared PD. Sorry, shared the persistent volume.
Yes, same thing. As far as I know, you can, because it's still part of the same pod template, like within the job. So you should be able to do that.
Okay, thanks.
All right, thank you, everybody. And see you next week. I'll be uploading this to YouTube for people who didn't see it. I think this was extremely useful, at least for me. It's really great.
Yeah, thanks for having me and for all your great questions.
Thanks. Bye.
That's it.